Hi there, folks. Today we're going to be talking about Module 3, Logic, and we're just going to be doing a brief introduction. And so symbolic logic is an approach to reasoning where we use symbols to denote when something is true or false and build a logical argument based on our understanding of the situation. For instance, we know that 3 is an odd number and all odd numbers are not divisible by 2. Can we say that 3 is divisible by 2? Well, that's a fairly simple example, but it underlies the power of logic. It is a tool to understand the nature of all things. What we're going to be doing is we're going to be taking this idea and basically combining mathematics with the language, whatever language we're dealing with. And to do that, we're going to start with the idea of statements. And so in mathematics, a statement isn't necessarily a fact or an opinion. It's just a declarative statement. And so an example, kind of a nonsensical example, is the moon has polka dots whenever the crabs migrate into the delta. And so there's two different types of statements. This statement was a compound statement because there was more than one idea in play. A simple statement contains a single idea, while a compound statement joins two or more statements together. If we think of this example of the moon, this is a compound conditional statement because it can be written in the form if then. If the crabs migrate into the delta, then the moon has polka dots. There are multiple ways that we're able to combine these types of statements. Four of the big ones are listed here. And so there is the conjunction, which is and. There is a disjunction, which is or. There's the conditional, which is an if-then, or sometimes just an if. And then there's the biconditional, which is if and only if. This is basically a condition going both ways. We also have the idea of a negation, which would be like not. And so in this case, if we're saying the moon has polka dots, the negation of that would be the moon does not have polka dots. That might be more accurate. Uh, we have symbols for all of these things. If we go back a slide, you can see some of these. And so our conditional is this arrow. You can see the not symbol here is represented one way. There are actually a couple of ways to represent not. Sometimes you'll see a tilde used. That said, much of the work we will be focused on is the idea of truth tables. And so truth tables are a way to determine whether an idea is true or false. And so we know how to write statements out. And what we can do is with these statements, we can state whether or not they are true or false by kind of going through all of the possibilities. And so consider the case of the moon has polka dots whenever the crabs migrate into the delta. We can let P represent the statement about the moon and Q represent the statement about the crabs. If we go up here, we can see that there are different options for P and Q. And so it could be that P is true and Q is true. Or it could be that P is true and Q is false. It could be that P is false and Q is true. Or it could be that P is false and Q is false. Those are really the only possibilities for those statements. Either they're both true, they're both false, or one is true and the other is false. Uh, Once we have those different conditions, we can try to understand all of the different things that could happen between them. In our case, it was a conditional statement. If one thing, then the other thing. And so it would be how we would be saying, if the first thing is true and the second thing is true, then the conditional statement itself is a true statement. And so in our case, if we know for a fact that the crabs never migrate into the delta, will our polka dot example be true or false? Well, if our premise turns out to be false, then our statement will actually always be true. It's a complicated thing to think about, and truth tables are going to give us a tool to analyze and better understand this approach to logic. Once we have the basics of truth tables figured out, we can go further and determine if arguments are valid or not. And so an argument is valid if the conclusion necessarily follows from the premises. An argument is invalid if it is not valid. Hopefully that one makes sense. An error in reasoning that leads to an invalid argument is known as a fallacy. And there are many, many types of fallacies out there. Oftentimes, folks will try and misdirect you or get you to think one way when that's not necessarily going to be the truth. For instance, if you were given a example of some similar situation, but it's not actually pertaining to what you're dealing with, it could lead you in the wrong direction. And so you have to be very careful when it comes to identifying fallacies. There are many types of logical fallacies. Being able to recognize them can help you evaluate the truth. And that is our brief introduction to Module 3, Logic. Good luck, folks.